All right, let's dive in. In today's world of data, you've got two major players, a super fast, high-performance data warehouse, maybe something like Azure Synapse, and then you've got a massive raw data lake. Now, the big challenge is always, how do we get these two to work together seamlessly? Today, we're going to look at the technology that bridges that exact gap.
So picture this. On one hand, you have your beautifully structured, high-performance SQL data warehouse inside Synapse. And on the other, you have this enormous data lake, just brimming with raw files, CSVs, Parquet files, you name it. The fundamental challenge is making them talk to each other efficiently. So, how do you actually bridge that divide?
Well, the answer is a really cool technology called PolyBase. The best way to think about it is as the ultimate bridge. It's like an express lane that connects your SQL engine directly to all of those files just sitting in your data lake. And it's designed to make that connection fast, secure, and honestly, surprisingly simple. So what is this thing really? At its core, PolyBase gives you the power to run standard T-SQL queries. Yep, the language you already know and probably use every day, directly against files in your storage account. You don't have to move the data first, you just query it right where it lives. And this is an absolute game changer for both data virtualization and for ingestion.
Now, to really get why this is such a big deal, we have to talk about performance. You know, traditional loading tools, they often push all the data through the single control node of your Synapse instance, and that creates a major bottleneck. PolyBase completely sidesteps this problem. It performs a direct parallel bulk load right into the compute nodes, which makes it by far the fastest way to get data into your warehouse.
Okay, so how do we actually build this bridge? It's not as complicated as you might think. It really just boils down to setting up three key components inside your database.
Think of these as the three essential ingredients. You have the credential, which handles how we connect securely. Then you have the data source, which defines where the data lives. And finally, the file format, which tells the system what the data actually looks like. Let's break each one down real quick.
First things first, security. You always start with security, right? A database scoped credential is just a secure container. It stores the identity, like a service principal ID and its secret key, that Synapse is going to use to get access to the data lake. This is great because it means your secrets stay safe inside the database, not hard-coded into some script.
Next up, the external data source. This is basically just a signpost. It tells Synapse where to find the data. You just give it the path to your data lake, and then you link it to that secure credential we just made in step 1. Simple as that.
And the final piece of the puzzle is the decoder ring, the external file format. This tells Synapse how to read the files. Is it a Parquet file? Is it a CSV? If it's a delimited text file, you can specify exactly what the separator is, like a pipe or a comma. This makes sure it reads the data correctly.
Okay, our bridge is built, all the pieces are in place. So how do we actually use it to get to the data? How do these three objects let us query what's in the lake?
This is where the magic really happens. We do it using a special kind of table called an external table. Now here's the cool part. This isn't a normal table. It doesn't actually store any data. Instead, it's just a metadata object that pulls together the credential, the data source, and the file format to create a direct, queryable link to the files in your lake.
And the syntax itself really shows you how simple this is. You define your columns, just like you would for any normal table. But then, in that with clause at the end, you just point it to the three things we already built: the specific location of the data source, and the file format.
And this is the crucial point, the whole reason we're doing this. Once that external table is created, you can query those files in your data lake as if they were a standard SQL table sitting right there in your database. A simple select statement makes Synapse go out to the lake, read the files in real time, and give you the results. It feels completely natural.
Okay, but let's be real for a second. Data in the wild is messy, right? It's never perfect. So we need a way to handle bad rows, and we also need a solid way to physically load this data into our warehouse for that top-tier performance. Let's see how PolyBase handles these very practical challenges. So what happens when things go wrong? This is a super common problem. You define your external table with, say, an integer column, but one of the source files has the word apple in that spot. Does the whole query just fail?
Well, thankfully, the answer is no. Your whole query doesn't have to crash and burn. PolyBase has some really smart error handling built right in. When you create the table, you can specify rejection options. For instance, setting our reject value of 100 tells PolyBase, hey, it's okay to skip up to 100 bad rows before you fail the whole query. This is fantastic for dealing with minor data quality issues on the fly.
So, querying data where it lives is awesome for exploration, but for that top-tier, lightning-fast analytical performance, you're eventually going to want to pull that data into a real table in your warehouse. And the absolute best way to do that is with a powerful command called CTAS, which stands for Create Table as Select.
And check this out. This single CTAS statement is incredibly efficient. It does everything at once. It creates a brand new, permanent table in your warehouse. It lets you define its distribution for optimal performance, and then it populates it by selecting directly from your external table. It reads from the lake and writes to a high-performance table in one seamless operation.
And honestly, this pattern, using an external table with a CTAS statement, this is the way to do it. It's the industry best practice, the gold standard. It is widely recognized as the most efficient and scalable way to bulk load data from a data lake into Azure Synapse. This should be your go-to move.
And that's pretty much the whole shebang. A complete tour from connecting to your lake to ingesting data like a pro. If you found all this helpful, you know what to do. Go ahead and like, share, and subscribe for more. It really helps a lot.
So there you have it. That is how PolyBase creates that powerful, seamless bridge between your data warehouse and your data lake, unlocking a universe of new data sets for your analysis. We'll just leave you with this one question to think about. Now that the bridge is built, what will you discover? Thanks for watching.